Okay. How y'all doing?
Good. How are you feeling?
I'm getting better.
How's your dad doing? Did he get home?
He's home. He's not quite mobile yet, but we're getting him there. I was there all weekend. His legs are still really weak. But we'll see how it goes this week. I'm almost back to normal. I don't quite have the energy. If I sit still all day, I feel normal. But then when I get up and try to talk, I get worn out. So I'll do a little bit today. And then what I do today will be done with test 1 information, and then Wednesday I'll just be reviewed, and then test 1 will be on Monday. This is what I'm adding today. Okay, 2 concepts I'm going to add for test 1, and then this will be it. Solution dilution is just, the idea is you dilute something. Let's say I had a beaker that's got that type of concentration in there. If I add pure solvent, which is usually water, and I filled it up some, and now it's more volume, but I've still got 1, 2, 3, 4, 6. So this is more dilute than this. This is more concentrated. And you can achieve that just by pouring the pure solvent in, and then you get a less concentrated solution. That's a dilution. This solution is diluted compared to this one. In fact, this one is created simply by adding that much pure solvent, and then you've diluted. The formula is very simple. M1V1 equals M2V2. Concentration of volume of the initial solution. And then your diluted solution is that. That's the concentration of the diluted solution, and this is the volume. So that's what those mean, and like any other algebra equation you've got, if you've got 3 out of 4 variables, well, if there's 4 variables in that particular equation, if you've got 3 out of 4, you can solve for the 4th. That's how all of these are. M, in our case, we'll be using molarity, that's moles per liter. Volume, as long as these have the same units, you don't have to make them liters. You could do milliliters or whatever, as long as they're the same. I think I can make that obvious as I go. It's typical, sometimes this is called the stock solution. Like if we need sodium hydroxide for a lot of different labs we do, or you work in an analytical lab somewhere, or a quality control lab, and you need sodium hydroxide for a lot of the different things you do, someone will make up a concentrated solution of a very carefully known molarity, and they'll just make a big thing of it. And then on any given day, if you need a certain amount of milliliters of a certain concentration, you can go over there, get some of this, do a dilution, and then make the solution you want very easily. So that's a typical thing to do in lab. We'll probably do some dilutions when we get back to doing labs later. And this is a solution you're making. Solution you are making. So that's it, the new concentration and the new volume. Notice the volume is always, you'll always have a higher volume once you dilute it by pouring that in, and you'll always have a lower concentration. So into is always smaller. So just some examples of this. I'm going to do some of these from the back of the book. I'll do the even ones. One V1 equals N2 V2. All right. Let me pop this up here. So in chapter 8.2, you skip down some until you see solution dilution. There's the famous formula. I'll just go ahead and use this as an example. Example 8.3. Volume. Liters. So what volume do you dilute to? That's this, the volume. So to obtain 3 molar NaOH. All right, and the key is just identifying what N1, V1, and 2V2 is. What volume, or does it say to what volume? Yes. To what volume? To what volume? So this is the starting solution. This is your final concentration. And that should identify the variables there, and the rest is just plug and chug. You've got 0.2 liters, and it's asking for a volume, so we'll do that in liters. 15.0 molar is this, so this is and of course that's 15.0 moles per liter. I don't think you really have to change it. I think you could just use it this way because this is so simple. I would just leave it like that with the capital M. The initial volume is 0.2 liters. So that's your initial volume and your initial concentration. This is your final concentration, so the N2 is, and then the question mark is the V2. What volume do you dilute to? And all you have to do is divide by N2, that'll give you V2. That's all there is to it. Meaning 15.0 capital N over 3 more, and that's going to give you liters. Oh, it's frozen. 15 times 0.2 divided by 3. We've got 3 significant figures. My calculator just says 1, but I want to put 1.00. That's the answer to this. And they got 1.00 years ago. And the rest of these I have back here in the exercises. So I'll do 36, 38, 40. So 36. So 36. That's in milliliters. Your 2 volumes need to be in the same units. And they've given us 150 milliliters, and then they said 2 liters. I will just turn that 150 milliliters into liters. So I've got that instead. Just move the decimal 3 times to the left. So as long as you have those in the same units. That is this. We want to know the new molarity. If we dilute 2 liters, then this, and that's it. Divided by U2 equals N2. So we just solve for N2. What is the molarity of the diluted solution? Do notice that grams are not mentioned anywhere. Therefore, there's really nothing to do with this. It really doesn't matter what the solute is. This is the solute. Once you put the solute, dissolve it into the solvent, then you have a solution, which is why we say solution for these. So this identity doesn't mean anything here. M1 V1 liters. Notice liters cancel. That's why you want the units the same, so they cancel. And we end in moles. I could go M1. I won't say that, but 0.125 150. 0.125 times 0.150 divided by 2. It's three significant figures. I get 0.00038 for M2. And notice I've got numerical value, unit, and usually I put a label here, but I really don't need the label for this because it's inherent to the context. So I'm not going to rewrite the calcium acetate. And this would be the scientific notation. So if you were asked for standard scientific notation, it's this. This is otherwise perfectly correct. That's good. I'll do a couple more of these two. All right, and now I'll do third and eight. Yeah, that was 36. Now I'll do 38. Diluted to, it doesn't even mention this on this one, it's diluted to 5 liters. So they don't even mention this time. That's the whole question. I've got milliliters and there's again, this is 0.2250 liters. And I would leave it like that. So now we got liters and liters. So again, the key is identifying which variables are which just by reading the question. If you can do that, the rest is very simple. I really should have 2 zeros here, because that's 4 significant figures. 2500 molar, and this is no. That was this. This is the 4 significant figures. 0.2250 liters. That should do it. I get, calculator says liters will cancel, you'll be at M. 3 significant figures, so 0.0281. That's the answer to the correct significant figures. Scientific notation. Do that. I'll do 40. was like the first one I did. I guess I'll erase all this. A 12 molar. $10. Look at the wrong problem. Do what volume change with 25? Sorry, I'm looking at the wrong problem. 25 milliliters, 10.0. 5 milliliters, 10.0 molar. To obtain again, grams per mentioned. So you don't need grams per mole, and this doesn't end up meaning pH to us. Doesn't matter what the solute is. All right. What is M1? This is describing the initial solution. So M1 is 10.0. V1, 25 milliliters. It asks for volume, but it doesn't say liters, so we can just use milliliters. This is the final concentration we need to get to into and V2 is what we're trying to find. So we're going to use and we'll just do it in milliliters. N1 V1 M2 10.0 times 25 divided by 0.150. My calculator says three significant figures, 3, 2, so that's what I'm keeping. This 6 rounds this 6 to a 7. Milliliters. That's the answer. If you wanted it in scientific notation, it would look like this. 1, 2, 3. And if we did it in liters, it would be so if nothing is specified more about the answer, if it were me, I would just leave it at 1,700 milliliters. If it wanted scientific notation, it'd be 1.7 times 10 to the 3 milliliters. If you wanted in liters, it would just be 1.7 liters. You guys okay with that? M1V1 equals M2V2. Other thing, solution stoichiometry. This is like the reaction that we were doing before, where you'd be given grams, and you'd use grams per mole, and then you would use the molar ratio and then grams per mole for the other thing. But this time we're using concentration. I'll show you what I mean. Back up here, solution stoichiometry. So example 8.4, here's the information you'd be given. And I'll do 41 and 42 as well. But this is sample in the book, in the chapter. And here's the way it would be asked. In liters. React with 0.150 liters on a 0.175 molar say solution. And you're given again the balanced reaction. 2 KCl plus 1 PB and 2 makes PbCl2 2. So there's the reaction. The ingredients for solving this, you've got this. You've got 150.150 liters of this. So that underlined and this goes together. All right, so you've got the volume, liters on a 150. So I'm here. Liters on a, what I put for the label here is KCl solution. I stick solution on there because this is volume. I'm going to use that. 0.150 liters. Right, 1.50 liters. Crap, this is a concentration. I shouldn't have put liters there. What I needed to do, because there's an N there, is go moles of KCl to 1 liter KCl solution. All right. Moles, it's just KCl. Liters, it's KCl solution. So this is just an expanded representation of this by itself. Or maybe I should include the word solution. So I've translated this into that. M just means moles per liter. And in this case, we're talking about KCl. So 0.150
moles of KCl put down in 1 liter of KCl solution. Okay, and this is what I was trying to do before. 0.150 liters. 150, correct? 0.150, 0.150, that's correct, it's just a little confusing. 0.150 liters of PbNO3 solution. That's another ingredient. And then there's this one with the capital M, that one's going to be 0.175 moles of PbNO3 2. That's another ingredient. There's one more thing I need. But notice 0.150 molar KCl solution, I turned into this. 0.150 moles of KCl to 1 liter of KCl solution. And then this, I turned into this. 0.175 moles of PbNO3 in 1 liter of PbNO3 solution. You with me? Peeling that out makes this a lot more helpful. Turning that into something a little more formal makes it all clear. This is kind of an arbitrary choice. It stands by itself. It's 0.150 liters of this solution. So that's why I had PbNO3 solution. This says liters, that's why I said dash solution. This says liters, that's why I said dash solution. I left the moles as they are. This was liters of a PbNO3 solution. So it's liters, so I'll put dash solution. Can you imagine what the next piece is? Molar ratio, it's the same as when we were doing reactions before and limiting reactant. I'm comparing these two things. So my molar ratio is 2 moles of KCl to 1 mole of PbNO3. That's the molar ratio from the reaction. Those are all the pieces. Now you just got to stack them together. So this gave me this in the expanded form. This gave me this in the expanded form. This was just a standalone PbNO3 liters. And then this is that molar ratio. And this is what I would start with. 0.150 liters of PbNO3 solution. And I'll just put it over 1. So we've used this. This tells you that liters of PbNO3 solution needs to be on the bottom. If you look here, only one of these has liters of PbNO3 solution. That's this one. So this is next. 1 liter of PbNO3 solution, and up here, we'll use those two. This tells you that moles of PbNO3 is at the bottom. If you look at what we've got left, only one of these has moles of PbNO3, and that's here. So 1 mole of PbNO3 to 2 moles KCl. So we've used this, and we're down to here. We need moles of KCl on the bottom, so I'm going to put that on the bottom next. It is 0.150 moles of KCl to 1 liter. And that'll do it. That'll give you what volume of a KCl, of this KCl solution. We end in liters of KCl solution. Liters. Calculator. All right. 0.150 times 0.175 times 2 divided by 0.150, and I get, my calculator says 0.35. It just didn't put anything after here, but notice that's exact, that's exact, that's exact, that's exact, that's exact. So we've got 3 significant figures, 3 and 3. So I need to write 0.350 for that. Again, I know it's a long walk. There is ways to work grams into these. There is ways to do limiting reactant, but I'm going to stop at that for test 1. So let me do a couple more things. So you guys get the odd answers, but I'm still going to go ahead and go through 41 and 42. And I hope to get, I did get limiting reactant stuff under reactions on D2O. There's only like 3 of them. Hopefully it's enough examples to practice. Maybe Lucy can come up with a few more with that section. And then there's the dilution thing that I don't have up there, and this solution stoichiometry that I don't have up there. Hopefully I'll get those up, but in the meantime, just study these to prepare for the test, and we'll see how my cold does and how my dad does this week, and we'll see what I get to. But those are there, they're just not as convenient as it being on D2O. But I will ask the questions exactly the same. Someone asked me earlier, do I need to read the chapters for the test? You don't. You do those quizzes, and if you can do those quizzes, you can do the test. I'm literally going to take the questions out of the quizzes, change some numbers, maybe change the solute, and it's going to be the same type of question.
The questions on the quizzes are correct. Thank you.
Are they? Are there any more mistakes on those? I think they're correct, yeah. If you think they're not, email me and I'll tell everybody. I think they're correct. Okay. All right. This is exercise 41 at the end of the chapter. Question is, what volume 0.150 molar Na3 PO4, and again, this doesn't matter unless grams is mentioned. They're just giving a specific example. Is needed to map with working in liters here, so I would just move the decimal back 3 places and go 0.0829 liters, and I'll use that. This is moles per liter. I'm going to expand that out. This is moles per liter. I'm going to expand that out. So we've got this to expand. We've got this to expand. That I'll expand a little just to add the CuCl2 solution to it. And then we're going to need the molar ratio. Here's the reaction. You'll be given the balanced reaction. Three of those to 1 Cu3 2 plus. There's the reaction. All right, so here's the pieces you want. Just starting here, being asked for volume, 0.150 m Na2PO4. I will write that as just to be correct, to 1 liter PO4 solution. I'm going to use that. All right, so that's this. I'll peel this one out next. 0.0121 moles of CuCl2 to 1 liter of CuCl2 solution. So there's those two things. Those are just essentially molarity expressed a little more formally. So that's this. This is referring to the CuCl2. So I'm going to write this as 0.0829 liters of CuCl solution. So there's that. And one more piece, what do I need? Huh? I've got that here. Molar ratio. I'm comparing this and this. So the last piece I'm going to need is 2 moles Na3PO4 to 3 moles of CuCl2. And there's all the pieces. And I'm going to start with this, like I said. You with me? I suggest going through it systematically like this, just so you don't get lost in it. All right, to build the equation, I'm going to start with this. 0.829 liters of CuCl2 solution. Put it over 1. This means liter of CuCl2 solution needs to be down here. We use this 1, 2, 3, 4, 5, 6. Of all those 6 things, only one of them says liters of CuCl2 solution. This one, liters of CuCl2 solution. So this is next. 1 liter of CuCl2 solution. 0.0221 moles CL2. Now we've used this. Next, we're going to need moles of CuCl2 on the bottom. Out of the 2 left, you only see moles of CuCl2 in one place. It's here. So this is next. 3 moles, 2 moles, and 3. And this says moles of Na3PO4. Use this. what's left for moles of Na3PO4 is this. So moles. .150. And 1 liter of Na3PO4 solution. And that ends on liters of Na3PO4 solution. And that's what you're asking for. What volume of the Na3PO4 solution?
Did you start with the volume like the other ones and then add to the volume? I mean, why did you pick to start with volume?
Just because it's neater that way. Because this cancels this, this cancels this cancels this. If I start with this, I can keep that pattern going. I could put this term at the front and it'd come out the same. It's just multiplication all the way across.
So there's not really a really wrong way to start.
No, you could mix these up however you wanted. As long as you have the right things on top and the right thing on bottom, algebraically, it's going to come out the same. I do that just because it's neat and it gives you kind of a tag to look at as you go. Because truthfully, once I write this first, only one of those things over there has CuCl2 solution. And then once I get that in, only one of the things left over there has moles of CuCl2. So it works out that you can use those as tags to help you build it across. But algebraically, you could mix it up. All right, and then the final step, good old calculator, 0.0829 times 0.0129 times 2 divided by 3 divided by 0.150. My calculator says 0.00445 81777 blah blah blah. And I'll do this again just to emphasize. It's basically the integers here. Exact, 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 exact. We don't need to look at those for significant figures. I used them in the calculation. Well, at least those I did. I ignored the ones. 3 significant figures, 3, so the answer needs to be 3. I'm aware of this every time I teach this subject. We beat you up on significant figures right at the beginning, but truthfully, we just kind of like stick to 3 most of the time. So if you're looking at this going, I thought significant figures was confusing. So 3, so the answer is 0.00446 meters. The 8 rounded to 5 up. And if you wanted that in scientific notation, 4.46 times 10 to the negative 123 liters of Na3PO4 solution. I know these are a long walk, but I go through them as systematically as I know how to do. Okay, I will do 42, and I just want to call it there. That'll be test 1. And then we can just review Wednesday. We go all the way back to the beginning to start reviewing Wednesday if you want. But do take note of these, just in case I don't get back to D2L. Hopefully I'll have my energy back Wednesday. I'm going to have to. We've got a lot to review.
Hey guys, we're gonna have an SI session tomorrow night at 6:30. We're gonna do some of the stuff from last week, like the
What time?
At 6:30.
6:30?
Yeah.
Where?
We're gonna do the in ANS. We're gonna do the limiting reagent stuff.
A&S, I don't know this campus. A&S, is that what you
Oh,
said?
the Arts and Science building.
Arts, oh, A&S.
Yeah.
Is there a room?
165.
What is it?
165. And we're gonna be doing like the stuff from last week with the linear reagent and reactions and stuff, the molarity stuff from today, and, dilution, and then also this stuff that, the stoichiometry that y'all are interested in. And then we're actually gonna start test prep tomorrow. So I'm gonna do like part one, I guess, or like a little bit tomorrow. Let's say a third of it.
At the same time, 6:30.
Yeah, and then on Thursday, it's gonna be the other 2/3, and then that Sunday is when we're gonna have the whole thing. But it really won't be productive if we haven't been studying before Sunday.
Yeah, if you waited to study, you got a lot to crunch, so do get on it. It's this, and then Saturday,
That's
Sunday.
tomorrow and Thursday, yeah.
this is Thursday?
Tomorrow, and then also Thursday,
Same time, same room?
yeah.
Tomorrow and Thursday, same time, same room on Sunday?
And then on Sunday, it's at
Sunday at 5?
Sunday at 5:30.
Sunday at 5 p.m.?
5:30.
5:30 p.m.
In the same time, in the same room.
All right, so y'all take advantage of that if you're feeling lost. So I'll do 42 next.
So, are they gonna need a scan from?
I can bring scantrons. Do other professors make you get your own scantrons? I've never done it. I've got a cabinet up there with a bunch of them.
This is one of my favorite.
Are they expensive?
No, it's just another fee.
Just
Another hidden fee I didn't know
I
about.
probably should ask. I'm probably supposed to make you bring them, but we'll save that for
Do
Kelly.
you like that? Don't worry
Well,
about it.
if the department nags me about money, I gotta go along.
I won't say.
I know what you mean, just a
I
little
won't tell
cost.
you don't tell.
All right, let me do one more of these.
Imagine you had money.
Cobalt nitrate. Cobalt 2 nitrate. All right, and the reaction here.
This is his second question. This is his second. What? Okay, that's just. But I don't even have
There's reaction. There's everything. Okay, where do I want to start?
Oh, I was about to say balance.
If you just start scanning across and you come to the first number, you've got that I will turn into 0.125 moles of Li2S to 1 liter, because it's a volume, I'm going to say solution. So if we got that, I'll go ahead and pull this one out next.
Thank you.
0.175 moles of cobalt nitrate. To 1 liter This is in milliliters, and I need it to be in liters. I'll just preload it by going that. And it's liters of that. So 0.225 liters of cobalt nitrate solution. And that's just standalone. That's 3 out of 4 things. What's the last thing?
Molar ratio.
Molar ratio. And it turns out that LI2S, Li2S. It turns out this is just 1-to-1, so it's one mole Li2S to 1 mole CO. There's all my pieces. And I'm going to start with this. Question?
I think your products are right.
My what?
The products, the elements are correct.
Oh, where did I get NaCl from? Oh, yeah, I read the wrong one. Lithium nitrate. These don't matter because we're dealing with these, but yeah, I do want to have it written correctly. 2Li3 to cobalt sulfide. And is it balanced? 2 of those, 2 of those, 1 of those. But we're using these, so that didn't matter, but still, I want it to be correct, so thank you. Okay, and what do I do here? Yeah, that's correct, it's those. All right, so there's all the pieces. Liters, cobalt nitrate solution. That means liters of cobalt nitrate solution is down here. The only one of these that has, we've used this, the only one of these that has liters of cobalt nitrate solution is here. So that's next. 1 liter of cobalt nitrate solution, 0.175 moles of cobalt nitrate. Now we need moles of cobalt nitrate solution. We've used this one. This is the only other one that has moles of cobalt nitrate solution. It's 1-to-1, so 1 mole cobalt nitrate to 1 mole Li2S. That's lithium sulfide. Now I need moles of lithium sulfide on the bottom. We've used this one. This is the only one that's left. There's moles of lithium sulfide. So I'm going to put that on the bottom. 0.125 moles. Yes. And then 1 liter. 1 liter Li2S solution. That will make us end on the liters of Li2S solution. And the rest is just calculating. 0.225 times 0.175 divided by 0.125. Calculator says 0.315. And the units are liters of lithium 2 sulfide solution. So if you wanted to do this reaction and you had 225 milliliters of this molarity of this, you would have to go get 0.315 liters of this to put it in there, and then it will react completely and make these products.
Did you have to change it to liters or did you like this?
Yeah, I had to change it to liters because the N is moles per liter. So those are all in liters. So I needed to turn this into liters so I could make everything cancel. I sort of preloaded it because that's kind of a simple thing to do, milliliters to liters. But I could have if you wanted to do the conversion really formally, let me take this term and slide it out over here. 0.225, no, not really. Let me take that. 225 milliliters of CO2 solution. Put that over one, and then what I would put here is, I didn't leave myself enough room, 0.225. That's 0.225. Now I would put milliliters of solution. 1,000 milliliters to 1 liter. Solution. And now liters this will cancel and the rest of it works. I just sort of preloaded this part and turned it straight into 0.225. Because dividing by 1,000 makes you go ding, ding, ding. So, but it's fine with me if you sort of preload it like that, and then everything else just flows. You guys gonna be okay? Do you feel partially ready for test one?
I'm gonna just tell my
She said, hell
kid.
no. Well, y'all get on it. You've got 1 week from now.
Let me.
You can review all you want Wednesday. I'll meet with you outside of class. Lucy's raring to go to help you out. Huh?